Hey guys, this is Dan with Pacific Tech Center, and I would like to introduce you to the first video of my series for Cisco Labs implementation. Basically, I need to refocus my time on Cisco Labs and prepare for a test I'm about to take in a couple months. I do not have the time to be able to do robotics and electronics and programming outside of what's needed for the Cisco test that I'm preparing for. If you know me, you know I've been a network engineer since 2001, and I have certification CCP security, enterprise, CCNA security, and enterprise of course as well. I have various certs that are no longer valid anymore, including the CCNA security. So CCNP securities and CCNP enterprise are pretty much the only relevant tests or certs that I have right now. And I'm preparing for more of a CCIE level test. So it really takes a lot of focus. I can no longer do other things outside of Cisco until I'm done with this test. So now you understand why I'm doing this. I do want to talk a little bit about the Cisco Modeling Labs. It is really an awesome product. I highly recommend it when you're preparing for any test, whether it's CCNA, CCNP, or CCIE, because they do have plenty of resources. However, if you do have CCIE level tests, there are going to be some additional things that you can't really do in Viral or CML that will require you to create external connections. And I will be on some of my labs. I will be doing that because I'll need to have, ICE and DNA and WSA, ESA. All those things are things that I will need to be able to do, and I'll figure those out. And when I do, I'll have videos of them. So this is basically a CCNA level introduction that I'm doing today. As you can see from here, it's very simple. I'm representing the internet or an outside company, and I have a firewall and then a switch and a user, basically. Everything on the outside is going to be 192.168.20. Everything on the inside is 192.168.1, just so you know. And we'll go through the script that I wrote. First, if you're familiar with the Python script programming for Cisco, CML, or Viral, you'll notice that I am using that, but I had to find some way of easily positioning the nodes in a diagram. And so in order to make it easy for myself, I wrote this. It's just keeping track of the positions, XY positions for each node and where I'm at any time. So if it needs to adjust, it's going to adjust each node before you actually draw it. So when you draw it, it's too late. That's why drawing is actually the last step you take before, after you've positioned everything else. So that's a really, really quick introduction into the class I created, and I will make that available on the GitHub that we have for Pacific Tech Center, the PTC GitHub, that you hopefully have already used to access the source code to the IBIS system and some of the other projects I have there. There'll be a new one called Cisco. So as I create labs, I'll make them available. Right now, this particular video is on the CCNA switch lab, which is that simple diagram I was just showing you. And as you can see, you create the lab, you create the nodes, you move them around as needed to represent the diagram that you did in Visio and what have you. You still need to do Visio because if you want to represent like areas and stuff like that, you're still going to need to represent that in Visio or whatever you're using the diagram things. Because when I show you the script, you will see why you still need outside sources. And I'll go ahead and run that. Now I pre-configured, the only thing I actually pre-configured in this script was the Linux system, because I don't really expect you to know how to set up an IP address on the Linux system. So I set it up here, but now that you've seen the script, you now know how to set it up. So anyway, let's go ahead and start it, and we'll go into each one. So I'll go down the line. Router 1, I set up one interface. Right here, I create one interface, and that router is going to be connected to the firewall. So you see the firewall 00 going to router 00. Here's where I create the interfaces for the firewalls, or for the firewall, I should say, and then the switch, the interfaces on the switch, and then of course the host. And here's where I link them. So, without looking at the script, if you didn't need to look at the script, you would just go over here, click on that node, and it'll show you the interfaces and where it's linked to. Let's start following the lab. So the host is already up. And you see the green circle with the checkbox means it's up, and we can finally access it. All the labs should be Cisco. And to show your IP address, you just do ifconfig -a for Linux. That shows you the IP address or whatever else is relevant for every interface. I could have said ETH0, and it would only show the Ethernet 0 interface. To look at the route table on a Linux system, you just do IP route. And you see the default route is here, and then the network route is here. So very simple. But again, this lab is for Cisco. We didn't need to get into the Linux stuff. I'm only here so I can do pings and what have you. And in later labs, we'll probably do like SSH and Telnet or whatever to do the different tasks for CCNA, for as long as we're doing CCNA level tasks. The next video most likely will be DMVPN, because that's the next skill that I need to get to the point where I can do within a minute or two. So I'll be practicing that one over and over again. But for now, I just wanted to show you the introduction of this. Let's go ahead and configure these things. Since the firewall is set up, I'll configure the firewall first. Again, Cisco is what I'm using for everything. And by default, there is no IP address. If you look at 00, you'll see that nothing's configured. So we'll configure the outside interface. Little IP address 172.16.20.1 class C, and this is outside. You can see from here that the outside interface by default is not trusted, 0 security level, and that's just how Cisco firewalls work. Is by default without an access list. Only more trusted devices communicate with less trusted devices. You can't go initiate communications the other way around. In this lab, we will, if you see on the validation, we will need at some point, we'll need the host to be able to ping router 1. So we'll explain that in a minute. But for now, let's now configure the inside interface. So the inside interface is 01. So let's go ahead and configure that. We'll go 192.168.1.1, again, another class C. And look at that. The security level by default for inside is 100. It's the most trusted. So I don't have to change that in any way. And now, if we look at the IP address assignments, we can now see that outside is 172.16.20.1 and inside is 192.168.1.1. Let's go on router 1. And as you see, we have no IP address on 00. We do want it 172.16.20.200 according to the diagram, so let's go ahead and do that. 172.16.20.200, and it is a class C, and we want to bring the port up. So I'm going to get rid of one of those annoyances, is those messages interferes with everything here. So I'm going to go ahead and turn on logging synchronous. now at this point, I've configured these two devices. So I should be able to ping them. I should be able to ping the firewall anyway. And there we go. Which also means from here I can ping the router. Let's go ahead and check out the switch, see what's in there. In the switch, you see there is no IP address, but as a layer 2 switch, it's everything by default is on VLAN 1. So interface 00 and 01 is on default, is on the VLAN 1. We did not set up trunking on the firewall or the host, therefore this should just work fine. So let's make sure I can ping the firewall, which I can, but I cannot ping 192.168.1.10. Well, why is that? It's because we never set it up yet. There's no IP address. Let's go ahead and set that up. VLAN 1. Remember, everything's VLAN 1 in this case. Ooh, look at that. So remember what I was telling you about the messages? Let's fix that. .192.168.1.10 is the interface IP address. And we want to be able to ping both the firewall as well as the host. So let's make sure that is the case. We can ping the firewall and the host. So it's all working. Just to validate, can we ping the router? Nope. There must be more tasks needed. So let's go over to here, and there's no reason to keep on pinging that and that. However, let's ping the router. Let's go and ping over and over again. This is Linux by default. You don't have to specify -C like you would on Windows. So it's pinging over and over again. If you remember right, here on the firewall, anything with higher security trust, if you will, higher trust, can ping or can communicate with anything lower trust. However, ICMP isn't TCP. Every path is a new connection. That means even if I can get to the router, and we'll verify that here. So from the router, or from the host, we're going to ping from the host, echo reply, and we're going to go to the router. Like I told you, it's allowed through, but yet it's not able to get to it. And the reason is because when the router replies, it's a separate connection and it's being declined by the firewall, and let's prove that. So if we do packet tracer and we go outside interface and we go 172.116.20.200, echo reply, and we go 192.168.1.50, it's being denied. And even if I was to switch around, right, because technically we're actually going the other way around, it's still being denied. And that is because we're going from a non-trusted interface to a trusted interface. And to correct that, we need to create access lists. Because now we want to say, hey, you know what, I want to allow this untrusted network to perform this task. So in order to do that, we would assign an access list. So let's go ahead and we'll create an access access list on the outside interface, and it's going to permit ICP any, and we're going to assign the access list to inbound, to interface, outside. And now, the moment we did that, should have worked. Hold on. Oh, and why it didn't work is because it doesn't know how to get back to the inside interface. So let's go ahead and create a route. To the inside interface. And there it is. Of course, what that also means is that here we should be able to ping 192.16.20.200, but it's not working, and it's for the same very reason that the router could not get there. Is because it doesn't know how to get outside of its own network interface. So here we want to go ahead and configure the default route. And this is a common problem, is a lot of times people think the firewall is blocking when really the device doesn't know the default gateway, right? Sometimes you have to get into the device and check the routing table just to make sure. And there you go. Well, that's it for this lab. I hope you liked it. If you like these type of videos, give me a thumbs up. If not, thumbs down. Subscribe if you like. And I appreciate everyone viewing this. Aloha for watching, or mahalo for watching, and aloha. I messed that up. Sorry.